In this part, we'll be setting up a trace channel for our lock-on system, as well as proper line-of-sight targeting to our enemy actors. The soft lock will not target any actor that isn't showing on the player's viewport, and we'll be optimizing the work we have so far to cap off our soft lock system. We're going to pick up exactly where we left off last time, with making an event that will handle our line-of-sight check, as well as make sure that our widget is toggled off if we are too far away from our closest actors. So below our Get Closest Target, we'll right-click and get a custom event. I'm going to call this LOS check. And this is going to consist of a line trace by channel. And we're going to get from the actor's location to the location of our selected target. So we run a trace directly from our player character to the target, and we want to ignore the targeted actors. That way, it will always return false, so long as there is nothing that is actually in the way. We'll get a branch after our line trace. We'll put another branch after our false result. And we're going to say, if we are a certain distance away, then we're going to toggle off the soft lock. We can copy our select target and soft lock widget, paste it to true. And we're going to check to see if our distance to target is greater than, we'll say 900. Then we're going to have the soft lock changed to hidden. And then on our event for getting the closest target, we'll call the event here. I'm going to change the draw time to 0.2 seconds and set the draw debug type to for duration. And so we can differentiate between this line trace and if we wanted to toggle on the get nearest target trace, and we're just going to change the trace colors. Now, when we get 900 units away, we could still see that this actor is soft locked. But at the end, we're going to drag in our LOS timer, and we're going to clear and invalidate timer by handle. And I'm going to make a new event for this, because we're going to have to call these two events fairly often. And we'll rename it Clear Soft Lock. When we get too far out, it disappears. We're still tracing to see what the closest actor is, because this is still within the sphere of our initial trace. So long as something is in this sphere, we're going to be checking to see what our nearest target is. Now, you can lower the radius of the multi-sphere trace if you want to, but functionally, when we have the player playing as it is now, it's not really going to change anything for them, and it's not going to add any overhead in your own game. Now, I'm going to switch the debug back to none, and we kind of kill two birds with one stone with this. We're going to have to come back and change some of this, but for right now, we're going to move on to getting actors that are only on this screen. I'm going to drag out the hit actor, and we're going to get actor location. And just to save some space, I'm going to collapse this to a node. I'm going to call it Get Actors on Screen. So there's a function called Convert World Location to Screen Location. However, you need to uncheck the context sensitivity. And make sure to recheck it, and we will get Player Controller. Connect that as the target. The world location is going to be our actor. Right-click on the screen location and split the pin. And right-click and we'll get viewport size. Again, right-click on the return value and split the pin. We'll drag off screen location X and get in range float. And then duplicate that. And we'll drag our return value X into our max. Then connect the Y values to the bottom. And we want to check player viewport relative. Then we're going to drag off the return node and we're going to get AND with 2 more pins. Make sure that all 3 of these are true. And then we can just drag out to our outputs to get a Boolean. Then back in our soft lock start, we'll add the value here. Actually, before I do that, to show you how it looks, when we careen the camera away, we still have these soft locked actors and they're still switching. But now because we have this screen location, it will limit what we have on the screen. One thing to note though, this get viewport size does say it is for cosmetic only. Now, testing this out for as many hours as I've done, I have not had any issues with this. The other way that we can do this is, instead of getting a multi-sphere trace in an area around us, you can also do a multi-sphere trace going out in a cone, or multi-line traces or box traces, or however you want to do it. But functionally, I found no issues with this, presenting other options. Now, since our line trace ends at what is essentially the pelvis of our third-person mannequin here, as soon as that gets off the screen, we're going to shift our focus of the soft lock onto the next actor that is fully on the screen. And if we don't have any actors on screen, there's no actors that are being put into our array. So our array is empty. There's nothing to soft lock onto. But because it's still running, as soon as we have something in view, we soft lock on. So let's test out our line of sight. If I just drag in this cube, we'll see our line of sight is showing as disrupted, even though we can clearly see the mannequin right across from the cube. What we can do for that is, off of our LOS check, we're going to add. We'll start off with 50 for our Z value. And if we test it now, you'll be surprised to find that it still does not work. If we go to our get nearest target, we have a line trace by channel. And if we set the duration, you'll find that that trace is also failing. Now, you would think that we could probably make use of some of this. Unfortunately, because I've already gone through this entire project, what you're going to find is that this is for a soft lock system. When we get into working with the hard lock we don't need to get a multi-sphere trace. We don't need to go and check the distance to every actor to see which one is the nearest. We're not going to be using this. So setting up a line of sight now helps us a bit when we get to the next tutorial. But we still want to have these traces be pretty similar. So if we add, we'll add 50 to our Z value, then we'll end that. Now you see that they both do the same thing. So we need both of these traces to be able to hit. However, both of these traces can be blocked by visibility. What we're going to set up is a new trace channel to be able to have our first trace get the distance between our actor, regardless of whatever objects are in the way. Then we're going to use the second trace that we just made and have it be the only event that handles line of sight. So if we go up to edit and into project settings, if we type in trace and go to new trace channel, we're going to, by default, ignore. And this is going to be our lock channel or lock on channel. The reason why we'd want to have this is that if we go to our get nearest target off of, sorry, not our get nearest target. If we go up to our multi-sphere trace, if we go up to our loop body and we go and connect the hit actors and we do a trace, you can see all the actors that we're getting, even though we only have 2 targets that we can get. So we're piling a lot of garbage into our multi-sphere trace that we do not need. So if we open up BP enemy and we go to our collision channels, collision presets, change to custom, and we want our lock on channel to block by default. Now, if we switch our multi-sphere trace to our lock on channel, we print. Now we are only going to be getting the enemies that we can put into our channel. Leaving our line trace for our line of sight check on visibility. And just setting this back to 0 so we can have it impact with the target. We can see that this is blocked, but it's still saying that our other actor here is the closest. So we are going to grab the targeted actors. If our line trace does hit an object and it's in the way of our targeted actors, and we wanted to remove the selected target, gets halfway there, but it starts flashing back and forth because we do our line of sight check after we get the closest actor. In order to change that, we need to essentially do this trace right before we get to the end of our loop, before we add the actor into the array. I'm going to copy the line trace, I'm going to paste it, and I'm going to collapse this to a macro. And this macro is going to be our line of sight macro. And I'm only really doing this to condense size. Because we're doing a line trace, we will need to have an execute. And we want to also be able to get our actor, because we can't call selected actor before we set what our selected actor is. On our input, we need to add type actor. We just call the input actor and connect the actor's location. Then off of our branch, we need to check to see, did this hit something? And because we're tracing visibility, we need to make sure that what this is hitting of the out hit, we can break, is the actor. We drag out the hit actor, type in equal equal. And then if it's true, we move on. We'll connect it right before we get the can be target. Now if we test this out, you can see that it does actually collide with objects in the way, so we're not assigning that actor the soft lock. And as soon as we walk out of the way of the geometry, it does. However, we have one issue, which is now both of these actors are being interrupted. So they are no longer in our area. However, they are not being targeted with the soft lock, but the widget does remain. So one thing we need to do, because when we get down to our get nearest target, if we remove the target before we get to checking to see whether or not it is the nearest target in the array, then we no longer can turn off its widget. So now a very simple thing that we could do is off of this false, we just take our soft lock widget made in part 1, copy it to the false, remove our selected target, and drag in our hit actor. Now, both of them are interrupted, the widget disappears. So let's double check our line of sight macro here for a second. This functions exactly the same to the event that we just made. So that makes this redundant. So this is only really good to see whether or not our distance is further away than what we want it to be. But if we go back into the macro and we add another condition to our AND branch, and we'll just flip this. So then if it is less than 900, and we can detach our line of sight check so it doesn't do anything. Now it still works perfectly fine. Now we may want to clear the soft lock at some point. The only difference between clearing the soft lock and, again, toggling off the widget is whether or not we want to end the timer. Which is effectively going to turn off all of our traces. We will need to do that when we get into the next tutorial, so I'm just going to put that over here, comment it, just so that we don't get rid of it. Then I'm going to delete the line of sight event. Then going back into our macro, because we're only getting a single line trace, it's not going to be that reliable. The endpoint is going to be centered on the actor, but if the actor is behind a chest high wall, for example, we may not be able to get a clear line of sight with a single line trace. So I would recommend that you have more than one line trace. That way, if you have one centered on the pelvis or another one centered on the chest, maybe you have a third one on the head. And if 2 out of the 3 of them hit the target, then it will soft lock the actor. Otherwise, the actor's too obscure for it to be selectable as a soft lock target. How you do this is going to be up to you. I figured I would mention that just so that you're aware, but for the purposes of this tutorial, I'm just going to keep this at a single line trace. we're going to have the actor location plus 50. We'll say plus 80. Should be roughly eye level. One last alteration I'm going to make is in the get nearest target function. We're going to change the trace channel to our lock-on channel, and we're just going to have our start be the actor location. This way, when we're not using our visibility, we don't have to worry about removing an actor, as now our line of sight macro is going to be the only thing that handles line of sight. So now that we're done with the soft lock, we'll be moving on to the hard lock in the next video, and we'll be touching up on the line of sight macro and doing some fancy camera work. So let me know if you liked the video by liking the video, and subscribe if you want to see more tutorials like this in the future. Thank you, of course, to the pillars of the Patreon, Francesco Poda, Thatcher Moss, and Winterberry Shark, and to everyone else who has supported the channel either through Patreon or Discord, both linked in the description. So with that, hope to see you all in part 3.